Hey, let me ask you a question here. Do you like rainbows? That's not actually the question. I just bring that up because we got some Roy G. Biv business going on here. My question, though, is hey, one of these things doesn't belong. Which one is it? So take a look. Maybe pause the video here so you can examine each one of these functions sideways and decide, for some reason, which one of these functions does not belong here. Which one did you guess? Because it's orange. The orange one doesn't belong because everything that's left over doesn't need the quotient rule. You can rewrite it. And as a matter of fact, that's what the first thing, whenever you have some sort of quotient, see if you can rewrite it, because if you can, it's going to make it so much easier to find the derivative. And the only one that you cannot rewrite to avoid the quotient rule is the one that's there in orange. So let me show you what that would look like. Then, right down here. And you know what? I'm going to color code this so that we look at the red. Hey, how can we avoid the quotient rule on red? Easy. It's just divided by 6, so you just rewrite that as y is equal to, say, 1/6 x to the second power, and then, let's see, 3 divided by 6, that one would be plus 1/2 x, right? You could take the derivative of that, so easy. Y prime is equal to, leapfrog that down, it'd be 2/6, which is a third x, and then plus 1/2. Look at that, no quotient rule. Can't do that with the orange. But hey, let's skip over here to green. Is that the right color for green? It looks like it's gonna be okay. Okay, so then for green, again, just like that first one, we'll rewrite that as 5/8 x to the fourth, and then take its derivative. Leapfrog that power down, so it'd be, sure, 28ths, but, you know, I could cancel out a common factor, make that cubed, reduce that fraction if you wanted to. All right, what about this one? We've got both in blue, let me change my color here. In blue, we have both a product and a quotient. Can we really rewrite that one? Apparently. PowerPoint says we can, because orange was the only one we couldn't. Can you see, like, let me zoom in a little bit. Can you see a little ghost image? I didn't line it up perfectly, so there was like a hint that it was orange. Okay, anyway, so if I rewrite this, distributing the -3 through the top, I would have a -9x, and then a positive 6x squared, and then I'm dividing this by 7x. Well, we have the same exact denominator, or variable, so we can subtract our exponents. It's going to make some fractions, but you know what? Those are going to be super easy to deal with. Like, for example, -9/7, and then the x's cancel. And then plus a 6/7, and then just x. And I would have to make some sort of note, of course, that x cannot be equal to 0. Because we have ourselves a line everywhere except at 0, where you'll have a point of discontinuity. Okay, and then purple. Dang it, ran out of space, but I'll just put purple over here. No, it's got to be the darker one, I'm thinking. Okay, I'll just put it right over here. So here you have the denominator having a variable in it. It's no worries. We would just write that as 9/5 x to the -2 power. Take its derivative thusly. So leapfrog that power down, and it's -18/5 x to the subtract 1 from that -3, and then rewrite it so it has a positive exponent. And I would have -18 over 5x cubed. Look at that, no quotient rule. Every single one of those. However, the one in orange, there's no way to rewrite this one. What's on top? Plus 1? Yeah. So y is equal to x plus 1 over x minus 1. Yeah. You could rewrite this as x over x minus 1 plus 1 over x minus 1 if you wanted to, but then you'd have to use the quotient rule twice. My gosh. Don't do that. No, we'll just keep it orange. So if I were going to take the derivative of this one, derivative of the top, which is just 1 times the bottom, x minus 1, minus the top one, x plus 1, times the derivative of the bottom, 1, over the denominator squared, x minus 1 squared. Okay, and then maybe just clean this thing up. X minus 1. I just distributed 1 through the parentheses. I know it didn't look like it did, but I did. And then I have to distribute -1 through this one. So negative x minus 1 over x minus 1 squared. Hey, it looks like things cancel like these guys cancel. I'm sorry, that was an ugly cancellation mark. And I have a negative 2 on top. So negative 2 over x minus 1 squared. Now, if we were going to find the second derivative of this guy, because we eventually will want to do that kind of thing, not for this one, but I could rewrite this like so. I could rewrite it as a negative 2 times x minus 1 to the negative 2 power and take its derivative. However, I don't have the tools necessary to take the derivative of this guy because you essentially have a function inside of another function. And in order to take that derivative, we need this thing called the chain rule. That will be coming to you pretty soon.